Good day. My name is John Vincent Saracanlao. You can call me Sir John or Dr. Saracanlao. So we'll do a summary of the data analysis that we've made and introduce frequency-based analysis. Another form of data analysis is frequency-based analysis. Typically, data analysis are categorized into groups. So we have one, descriptive, that is when X variable and Y variable are calculated separately and individually in terms of responses, whether it is calculated individually or as a group or category. It makes use of mean, standard deviation, frequency, and percentage distribution, skewness, and kurtosis. The second form of analysis is comparative, that is when responses or the results of the Y variable, dependent variable, is grouped together in categories of X variable or the independent variables, such as performance when grouped according to gender, male or female, academic performance when grouped according to attitudes, negative, positive, very positive, in which when comparing groups, we use t-test is used, comparing two groups, t-test is used, and f-test is used, and analysis variance is used when comparing three or more groups. The third is correlation. This is when the x variable, independent variable, is correlated to the responses of the y variable or dependent variable. This will make use of Pearson R, Spearman, and Kendall rank correlation. The fourth is regression. Though categorically regression falls under correlation, the distinction is correlation is calculated with two variables, multiple regression, and it calculates its relationship. Regression can calculate two or more variables, and the result does not only indicate relationship between x and y, but calculates the predicted value of y in relation to x, which is your dependent variables. All four models of data analysis make use of response versus response data analysis. And of the four, three will require distribution, normal distribution of data, normal distribution of data. However, there are data analysis that does not calculate response and response versus response data, but with frequencies. Though intercepting data can be calculated, intercepting x and y, it does not require normal distribution of data, one of which is chi-square. So frequency, when we talk about data analysis, we have response versus response. We also have frequencies and frequencies. So all those four data analysis will require will be requiring response versus response analysis. But there's also data analysis that does not analyze based on response versus response, but on frequencies. One of which is chi-square. We also have chi-square. I'll also be discussing contingency table. Also have descriptive analysis. We also have data probability and chi-square as a group. So those are the three statistical tools that you can use when data are technically not normally distributed, but they are tools that are very useful, and yeah, they're useful and you can really use them in your research when it comes to normality, collinearity, and all those things that stops you from moving forward. So there are other ways to move forward. So less on the anxiety. Okay, so I'll be discussing first chi-square, and I'll be discussing, so it's continued descriptive analysis and data probability. Okay, so let's start. This is quite a long discussion. However, this is the last discussion. This is the last lesson. And All lessons are done by today, and I'm calling the publisher now later because we're already set to publish, and all the things that has to be done should be done by today or before the end of the Lunar New Year 2024. It's February 25. So I think things are doing well for me in my part. My West credentials are being processed, just waiting for certification. Yeah, I think 2024 is gonna be nice to me, and I hope it will also be nice to you. I really hope that this book will help you understand research statistics more and lessen your anxiety on it per se. So this will guide you. I will guide you. I will help you. We'll just find a platform that we can connect, and so I can help you. So let's go to chi-square. Chi-square is a way to compare the data collected whether the variation is due to chance or is due to other variables related to the data. It is a measure of interdependence of variables, thus basically to evaluate that data whether it is purely by chance or not. So when we have chi-square, we're talking about observed data and expected data. So we're trying to figure out if the observed data and the expected data exist purely by chance or there are other, what you call this, influences or manipulation that by calculation states that the observed and expected data did not happen by pure chance alone. Something is influencing the data for it not to exist by purely chance alone. So chi-square is the sum of the observed, that's O, minus expected values over expected values. The data is observed data is the value based on experiment. Ideally, there should be 30 and above observations. For example, flip 100 coins. Based on experiment, there are 62 heads and 38 tails. It could be 55 heads and 45 tails. It could be 48 heads and 52 tails. Whatever the outcome, those are your observed data. Expected value is a theoretical value of the data. So, for example, if you flip a coin, theoretically there should be 50 heads and 50 tails. And they don't have to be a whole number. For example, if you have 51 coins, the expected value is 25.5, 25.5. So I hope you understand. We are on the same page on observed values and expected values. So observed values are the outcome based on the experiment or the data. And your expected is a theoretical calculation of those outcomes. So in chi-square, the goal is to compare the variation of data from expected data. Thus, the hypothesis is, and null or structured are as. There is a significant difference between the observed and expected frequencies. And the null, there is no significant difference between the observed and expected frequencies. So reject the null if the result after computation, the chi-square is higher than the critical value. And you accept the null if after the computation, the chi-square is lower than the critical value. Data need in calculating chi-square. So you have your observed values and expected values in the form of frequencies not responsive. So degrees of freedom, possible outcome -1. In a coin, there are two coins. That's two outcome. That's head and one tail. So in a dice, you have six. Thus, your degrees of freedom is five. Since you have possible outcome, minus one. So from head to tail, you have one head and one tail. That's two minus one. And in dice is six minus one. That's five. Okay. So level of significance default is at 0.05, which means 95% confident to the conclusion. Choosing level of confidence is choosing level of significance is discretionary. So critical value is based on for accepting and rejecting the null. So based on the experiment, 50 coins were tossed. The observed values are 28 heads and 22 tails. So we have our contingency table here. So we have 28 and 22. That's our observed. Our expected is 25 heads. We're expecting 25 heads and we're expecting 25 tails. So calculation here, that's the square of the observation, the first observation and the second observation. It's the sum of the square of observed values minus expected values over expected values. So we have something's wrong here. The expected value should be under here. So 28 minus 25 squared, expected values, plus 24, 22 minus 25 equals to 9 over, yeah, expected values over 25 and over the first observation is over 25, and that is over 25. And that's 9 over 25 is 0.72. So from that, we will now look at our level of significance, our degrees of freedom. So we have our level of significance, as I said, is zero point 0.5, and our degrees of freedom is 1 because that's two observations, head and tail, minus 1. So we're looking at this critical value. So thus, our 0.72 is right here, and our critical value is at here. So when we say our critical value is here and our chi-square is less than our critical value, then we accept the null, which is accept there is no significant difference between observed and expected frequency. So yes, there is no difference because technically by observed data versus frequent expected data, everything happened in a way that it existed by chance chance alone, which could mean that the coins were normally tossed and the outcome is based on chance alone. There was no manipulation. You did not throw the coins and flip the others. So or use something that influences the data. So there is no significant difference between observed data and expected data. It means that coins were normally tossed and the outcome is based on chance alone. So that is how you theoretically use chi-square. And in contrast, the null is rejected. This, if ever the calculation is around here, like 4.84, in contrast, the null is rejected. This means the outcome is not based on chance alone. There is factor that influences the outcome. The factor that influences the outcome is not usually stated in the data as a variable, but the variables used during the experimentation. So yeah, So there's something that influence, but it is not stated in the data. But during the experimentation or during the process of gathering the data. So layouting procedures for contingency table. I think I need to stop there because this is quite a long topic and it's separate, connected but separate in a sense. So yeah, because we'll be doing the other types of tests in a while, which is descriptive analysis, frequency-based descriptive analysis. We also have data probability, and we also have chi-square. That's not just more of a summary from our contingency table. So as for now, I'll end the lesson here, and I will continue with the next topic on contingency table. I hope you understand chi-square. Remember that it's about observed and expected, and is there significant difference between observed? Is there a difference between observed and expected results from which you either accept or reject the null? And so I'll be continuing in a while. Thank you for watching. The book will be published within this week or next week or before the end of the Chinese Lunar New Year for 2024. Thank you and have a great day.